Welcome to our physics video, where we will be covering speed and
velocity, like we always do with this time. I got to shine.
Speed is the rate that a distance is covered.
And velocity is speed in a given direction.
Now let's get to the experiments. Speed.
Speed. In our first experiment, we'll be using cars measuring their speed and velocity using this radar gun and the speedometer.
The speedometer shows instantaneous speed, which is speed at any instance. Now let's go test this out.
The formula for speed is distance over time.
We're going to use that formula using this car to see when we do the calculations if it matches up to the speed on the speedometer. The car is going to travel 500 feet and we're going to see what happens.
Before driving any car, you should always remember the first thing to do is buckle your seatbelt. And make sure you hear the click. Next, check your mirrors. Okay. Foot on the brake. Insert the key. Start it up. And you're ready to go.
Speed is known as a scalar quantity. Scalar quantity is a quality that describes how much magnitude. Now we're going to look at that speed on his car. Distance and time can also be known as scalar quantities.
I'm at the 500 feet mark. Here comes Justin. 38 miles per hour. The formula for speed is distance over time. So when Justin was driving at a constant speed, he went 200 feet. So you put the 200 in the numerator, and then he went that far for 5 seconds. So you put that in the denominator, and when you plug that in, like so, the speed should be 40. Now the car speedometer read 40 and the radar gun read 38, so we were around the right number, which shows we had good stuff. Velocity. Velocity.
Velocity is known as a vector quantity. Velocity can be experienced in this car as well when going around a turn. A vector is known as a quantity that describes how much and which way magnitude and direction. Now let's test this out. Vectors can also be known as displacement and acceleration. Notice how we're going at the same speed as we were before with 40 miles per hour. As we approach the turn, you'll notice his speed being changed because velocity is occurring when going in a turn.
Coming around the turn, notice the speed change. Much slower. His velocity changed because he had to slow down for the turn.
So the formula for velocity is v equals x over t, in which x is the displacement and t is the time. So v equals the 250 divided by the 15, and then that on the calculator equals, so 250 divided by 15 equals 16.6. This is the same exact number that was shown on the radar gun just a little off, so it shows that our calculations were pretty close to what the radar says.